Lesson 8-3, represent a linear function. In this lesson, you're going to learn how to solve linear equations with two variables and graph linear equations using ordered pairs. In the past, we've already defined the word function. The function is when the domain does not repeat. A function, again, is when the domain does not repeat. We've associated the domain with the x value, and that's going to become very important in this lesson. Although we have 4 new vocabulary words, we're only going to focus on linear equation for this lesson. We'll delve into the other 3 in a later lesson. So we're going to look at the why question. It says, in a tennis match, Venus Williams serves a tennis ball at a speed of 60 meters per second. Now with that question, we're going to focus on A, B, C, and D of the why question. It says complete the table to find the number of meters the tennis ball would travel in 1, 2, and 3 seconds at that speed. So they set up the table for you, and they've labeled your table with a title. Time in seconds is represented by X. Time in seconds is represented by X. Again, that's our input. Remember in lesson 1-5, we focus on our input and our output, meaning the same thing. So this is my input, and Y is the output of my function. So if I put in X, I get out Y. Okay? So my equation, 60X, because it goes 60 meters per second. So I plug in 1 for X. 60 times X is 60. We have 60 times 2, which is 120. 60 times 3, which is 180. It says, on grid paper, graph the ordered pairs. Notice they don't give you a section for your ordered pairs, so I'm going to extend the table out. My ordered pairs will be 160, 2, 120, and 3, 180. Just squeeze it in here, trying to be neat. Okay? So on graph paper, we would graph this and then connect the points. Then we would have to come back and answer the question, do the data represent a function? And again, if the domain does not repeat, it's a function. And then the challenge is write an equation representing the relationship between X and number of Y meters. Okay, let's look at solving linear equations. An equation such as Y equals 60X is called a linear equation. A linear equation is an equation whose graph is a line. So in the end, we're going to be graphing a line. A linear equation is also a function because each member of the domain, which is our X value, is paired with exactly one member of the range, our Y value. All of this should sound familiar to you because of our previous lesson, 1-5. The solution of an equation with 2 variables consists of 2 numbers, 1 for each variable. That makes the equation true. One way to find a solution is to make a table. Now we're going to look at some problems and work through them, but here are the steps we have to follow for each table that we create. Step 1 says choose 4 values. We must have 4 values for X and substitute each value into the equation. Now, rule of thumb, and to make this easier for you all, I would suggest always choosing these 4 numbers for your X value to be consistent. I would say always choose -1, 0, 1, 2. It will make it a whole lot easier. Again, you can choose any numbers that you want, but I suggest choosing these four because once we start working problems, you would see the tables repeat using these and you would get in the habit of having a set number that you choose. Now, once you put those into your table for x, it says evaluate the expression to find the value of y. So they substituting x from the equation 7x. Again, this is an example that they're going over with you. So I'm replacing x with a -1. 7 times a -1 is a -7. And my ordered pair is the values from this column paired with the values from my y column, which gives me my ordered pair right here. These are the values that we're going to have to graph. We're going to graph or plot these points on a coordinate plane. So you're going to have 3 steps you're going to have to do. You're going to have to choose 4 values. And again, we're choosing the same 4 every time. We're trying to work smarter, not harder. Then we're going to evaluate the expression, remembering our integer rules and order of operation. Then you're going to write the solutions as ordered pairs, this third column. And I like how your textbook labels each step for you. Step 1, step 2, where you get your output, and then your ordered pairs. So your solution for y equals 7x are -1, -7, 0, 0, 1, 7, and 2, 14. Now we're going to graph this information. We're going to graph this. So we're going to graph on my freehand coordinate plane. Graph this. So this is my y-axis, and this is my x. Now we will use graph paper in the classroom, so it won't be this unorganized, but this is just to give you an example of how your end result is going to look. Trying to have 14 tick marks here. Okay, and then on my y-axis, I need so many. And on the negative side, the maximum I need is -7. I don't need any -1 here. So we're going to graph the ordered pairs from our table. So my first ordered pair is -1, -7. We're going to go -1, negatives are to the left, and then we're going to go up, go down -7. 1, 2, 3, 4, 5. Oh, I need to add more. We add more lines. So negative 1, 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 7. Them have 0, 0. That's the origin. I'm not going anywhere. 1, 7. 1, 2, 3, 4, 5, 6, 7. And then 2, 1, 2, all the way up to 14 in my imaginary space. Trying to line it up. We'll just guesstimate that it's right there. And then we have to connect. Now be mindful, it has to be a linear equation, meaning that it has to give us a line when we connect. And we have a line. So we can answer the question that this is a function because we see that none of our x values are repeating. We have negative 1, 0, 1, 2. And since they're not repeating, it's a linear function. Now we're going to work through 1 together versus just looking at it already done for us. We're going to work through 1. I've already set up everything here. So it says find 4 solutions for each equation. Write the solution as ordered pairs. I set up the table already for 1D. I'm not going to work through all of these. We'll just do 1D. So what's going to happen is this. Again, I chose the same 4. Recall that I said it's easier to choose the same 4 that they already have in the text. So I chose negative 1, 0, 1, and 2. Then I set up my table where I can plug in for x, where I can plug in for x, okay? So every time I work the equation, I'm replacing x with what's in the x column, negative 1 minus 6. Now I told you to recall your integer rules. I'm going to come over here and do scratch work. So I have negative 4 minus 1 minus 6. A negative times a negative is a positive, so I'm going to get 4 minus 6. Remember my integer rules for subtracting. The smaller number in front, I have to do keep, change, change. And now I have to add. So I have more negatives than I do positives, so I'm going to get negative 2. So my y is negative 2. And my ordered pair is going to be negative 1, negative 2. Again, same thing. Now I'm replacing with 0 for x. So negative 4 times 0 is 0. I'm left with negative 6. So my ordered pair is 0, negative 6. Plug in for 1. Scratch work over here. Negative 4 times 1 minus 6. I get negative 4 minus 6. Keep, change, change. I have a negative 10. Y equals negative 4 times 2 minus 6. Scratch work, that's a negative 4 times 2 minus 6. Negative 8 minus 6. Keep, change, change. It's a negative 14. Now I come back and write my ordered pairs. 1, negative 10. 2, negative 14. Then we would graph our ordered pairs right here and connect the dots to form our linear equation. As you can see in our table, we keep increasing by 4 every time. We keep increasing by a negative 4, and that's this negative 4 right here in the front. So things to remember for this lesson: you have to remember what a function is. You have to remember your integer rules when you start evaluating the equations, and you have to remember order of operation, multiplication before addition and subtraction. We're going to review in class on Wednesday We're going to review in class on Wednesday graphing, integer rules, and order of operation. So this lesson would be a breeze for you if you can recall those three things. And I hope you have a great day.